students, myself Jarnail Singh. Today I am taking a topic from 9th standard, Newton's second law of motion. So we have discussed earlier Newton's first law of motion. Now today I will discuss second law of motion, and according to the statement of Newton's second law, that the change in momentum of a body per unit time is directly proportional to the unbalanced force acting on the body, and the change in momentum takes place in the direction of the unbalanced force. Now say we have a body, now we will apply a force, then that body has change in momentum, and that change takes place in the direction of the applied force. Next, consider a body of mass m having with initial velocity u. Now let a force F is to be applied. Now here is a body of mass m, and F external unbalanced force is applied here when time t is equal to 0. Now that body is moving with initial velocity u. Now after time t, the body will attain a velocity v. Now what we have to find, that initial momentum of the body. Now initial momentum of the body, that is represented by letter pi, that is equal to m into u, means mass of the body into initial velocity. Then final momentum of the body, that is pf, is equal to m into v, mass into final velocity. Now the change in momentum, that is equal to pf minus pi, means difference of the two momenta, that is final momentum minus initial momentum. Now which can be written as mv minus mu, which is equal to m common and into v minus u. Now we have to find the rate, because according to the statement of the second law, rate of change of momentum, which is given by change in momentum divided by the time. And when we put the value of change in momentum, that is m into v minus u upon t, then according to the definition, that the force is directly proportional to the rate of change of momentum. Now since we know that velocity v is equal to u plus at, so we can find here a, so that a is equal to, that is equal to v minus u upon t. So we can replace here this v minus u upon t by a. So F is directly proportional to now mass into that a, acceleration of the object. Now F is equal to k into ma. Here k is the proportionality constant, and if the value of k is 1, then F is equal to ma, means force is equal to mass into acceleration. So Newton's second law of motion gives us the measure of force, and that force is equal to m into a. So this is all about Newton's second law of motion. Thanks.